Hello, math students. Today we're going to be going over writing and solving systems using elimination. So in the previous two lessons, you probably saw writing and solving systems using substitution, and then also writing and solving systems using graphing. But in this case, we're going to be using the elimination method, and in my opinion, it's the easiest way to solve these systems, and also kind of the trickiest to understand what's happening. But if you get enough practice and you see what it's like, then it makes a lot of sense. And so just follow along, do everything I do, and I guarantee you it'll make a lot more sense. So let's go ahead and start the tutorial. Here on page 5, it says the sum of two positive numbers is 37. So that tells you your first equation right away. The sum is 37. That means that when you add the two numbers together, that they add up to 37. The sum means you add them together. So our first equation is that x plus y, the sum is 37. Now the second equation just comes from this next part here, and their difference is 7. That means when you subtract them, the difference between them is a subtraction. So when I subtract them, the result is 7. So those are our two equations there for the system of equations. So there you go. All right, let's go ahead and move on. And we could just skip ahead to wherever it stops us with problems. So here it stops us here on page 12. So let's go ahead and answer this question. All right, solve this system of equations using the elimination method. So here's where we're going to see how the elimination method works. And generally, when we have this system of equations, there's a few things we want to set up before we use the elimination method. And the first thing we want to look at is everything lined up? So what do I mean by that? So your x's need to be like in one column, your y's in another column, the equal sign, and the constant. So you can see that here. See how the x's are lined up vertically? The y's are lined up vertically. The equal sign is lined up vertically. And then the constant is lined up vertically. So everything of its type needs to be lined up vertically like that. So if it's not set up like that, then you need to do a little bit of work to set it up like that before you could use the elimination method. Now, here it's already set up perfectly how we like it. So that's great that we don't really have to do anything to make it that way. But let's go ahead and see what other piece of information we need in order to use the elimination method. So as the name suggests, the elimination method is you want to eliminate one of your variables. So you either want to eliminate your x's, get rid of your x's, or eliminate the y's. And sometimes it's easier to eliminate x, sometimes it's easier to eliminate y, sometimes it's not easy either way, or it's equally easy either way. So what I look for is, well, if I add these together right now, if I added these equations together, would my x's cancel? So 3x plus 2x, would that cancel? Would that eliminate? Well, no. 3x plus 2x is 5x, right? What about our y's? Would they cancel if we added these together? Well, no, not here either, because negative 2y plus y is negative 1y. So in this case, if I add the equations together, nothing eliminates. The x's don't eliminate and the y's don't eliminate. So what you'll have to do in cases like that is you'll have to multiply one of the equations, or sometimes both equations, by some number to cause elimination. So let me show you what I mean. In this case, it's easiest to eliminate the y's. So what I'm going to do is, I notice for the top equation, it has negative 2y. Now, if I make positive 2y in the bottom equation, then that would eliminate, you see. So I'm going to go ahead and multiply this bottom equation by 2. So what happens? Well, my top equation doesn't change. So it's still 3x minus 2y equals 0. But the bottom equation, I'm going to multiply every term by 2 in this case. So the 2 gets multiplied, it's distributed to everything in this equation. So that's going to be 2 times 2x, that's 4x. Then 2 times y is positive 2y. And then equals, the 2 also multiplies with the 7 there, so 14. Now, you may notice that when I add these two equations together, notice what happens to my y's. Well, they eliminate, right? That's why it's the elimination method. Now, they eliminate, but the x's do not. See, 3x plus 4x, that's 7x. And then equals, and then 0 plus 14 is 14. Now, once we've eliminated the y's, it's very easy to solve for x. How would I solve for x from this point? Well, I would divide both sides by 7 to get x by itself, giving us that the value of x is 2. Okay. Now we have our x value. See how fast that was? It's much faster than substitution in many cases. Now that I know my x value, I can actually use what I learned from the substitution lesson and substitute this value 2 in for x in one of our original equations. You could use either equation. They both work equally as well. So I'm just going to go and replace it into this bottom equation. So I'm going to replace the x with the value of x here. So 2 times x becomes 2 times 2, substituting the x for 2. We have a plus y equals 7. So again, I'm just rewriting this bottom equation, replacing the x with 2 in this case. Let's go ahead and solve for y here. So 2 times 2 is 4. So we have 4 plus y equals 7. Now, how would I solve for y here? Well, I'd go ahead and subtract 4 on both sides of the equation, giving us the value of y is 3. So what is the solution for the system? It's 2 for the x value and 3 for the y value. If you were to graph these two lines, you would see they would cross at 2, 3. They would cross at that particular coordinate point. Okay, so here, 2, 3. There we go. Let's go ahead and move along. So that was your first example. And honestly, that was about a medium level example. There are easier ones, but there are certainly harder ones. We're gonna get a lot of practice doing these, so just follow along and do every single example, write down everything I do, and it'll make a lot more sense for you, trust me. Okay, now I'm on page 16. Here's the activity portion. A test is worth a total of 150 points and contains 70 questions. Some of the questions are worth 2 points and some are worth 4 points. So the first thing we want to do is create a system of equations. Okay, so the first equation in the system of equations that models the situation is x plus y equals 70. So they give you the first equation straight off the bat, x plus y equals 70. So x is the number of 2-point questions and y is the number of 4-point questions. So when I add the number of 2-point questions plus the number of 4-point questions, well, that's 70 questions in total, it says. There's 70 questions, okay? X represents the number of 2-point questions, y represents the number of 4-point questions. So this first equation has to do with the quantity of questions, in this case, 70 questions. Now, the second equation we're going to do has to do with the value for each of these question types. Well, each of the 2-point questions are worth 2 points. So for each of the 2-point questions, which x represents the number of 2-point questions, each of them are worth 2 points. Can you guess what I'm going to put for B? If you guessed 4, you're correct. And this will give you the total value of all the points in the test. In this case, how many points are on the test? It says up here, 150 points. So 150 goes here. So now you have your system of equations. We have our first equation, x plus y equals 70, and our second equation, 2x plus 4y equals 150. Let's go and move on to part B. Let's go ahead and solve your system of equations from part A using elimination. Then complete the statement. The test has blank questions worth 2 points and blank questions worth 4 points. So I'm going to go ahead and use this system of equations. Let me just grab this one here, and I'll just write the second equation above it. So the second equation, or I guess it's the first equation, x plus y equals 70. Now we're going to use elimination to help us solve for these variables, x and y, solve this system. Well, I notice, first of all, one good thing is that everything's lined up, right? Our x's are lined up, our y's are lined up, the equal sign, and the constant. So everything's lined up perfectly for elimination. So that's good. Now, the second thing I look for is if I add my x's together, will they eliminate right now? Well, no, they won't. X plus 2x, that's 3x. Similarly, our y's would not cancel either. Y plus 4y is 5y. So I need to multiply. I'm going to multiply this top equation by something to help me eliminate one of the variables. If I want to eliminate the x's, I would multiply by -2. That way it'll be -2x and then a positive 2x down here. If I wanted to eliminate the y's, what do you think I would multiply by? Well, I'd multiply by -4. So it just depends on what you want to eliminate first. Sometimes it's easier to eliminate x. Sometimes it's easier to eliminate y. In this case, it's about the same amount of easiness either way. So it just depends on what you want to do here. Here I'm going to multiply by -2 and eliminate the x's. So let me go ahead and distribute that -2, and then we'll have basically a new version of this equation. So that'll be -2x minus 2y equals, and then it'll be -2 times 70, that's -140. Okay. The second equation didn't need to change, so I'm just going to rewrite it. Sometimes you'll have to multiply this equation by something too, but in this case, you only have to multiply the top equation. So, all right. Now when we add these equations together, what happens to my x's? Well, hopefully you can see that the x's eliminate. That's good. Now we have our y's. -2y plus 4y is positive 2y. It's positive because we have more positives. Equals, what's -140 plus 150? Well, that's 10. Okay. Now let's go ahead and solve for y. So how do we solve for y from here? Hopefully you know this, but we divide by 2 to get y by itself, canceling the 2 here, and then dividing by 2 on the other side as well. 10 divided by 2 is 5. So we know the y value now is 5, and we can use that information and substitute it back into one of the original equations to help us find x. I'm going to actually plug it into the first equation. So I'm going to replace this y right here with my y value of 5. So this equation that was x plus y equals 70, now it's going to say x plus, what's the value of y? 5 equals 70. Okay. Let's go ahead and solve for x. What would I do to solve for x here? Well, hopefully you see I would subtract 5 on both sides of the equation, giving us the value of x is 65. All right. So that means it has 65 2-point questions and 5 4-point questions. And there you go. Let's go ahead and move along, move along, move along. Here we're going to talk about how many solutions something has. So sometimes a system of equations has one solution. That's the most common result. Sometimes a system of equations has infinite solutions, and sometimes the equations have no solution. Now, we've talked about this prior, but let's go ahead and I'll re-explain that. If they have one solution, that means on the graph, that means they cross at one location. So in the result of one solution, you find the solution, that's it, okay? In the case of, and it gives you some coordinate point, like an example might be 5, -1 or something. Okay. Sometimes the two lines are parallel. So how many solutions do parallel lines have? Well, we talked about this before, but parallel lines have no solution. So no solution. So no solutions. And when you try to solve using elimination, what ends up happening is you end up with something not true. You'll end up with something like 0 equals 6 or something like that. Well, this is not true, right? So if you end up with something that's definitely not true, like all your variables got canceled, there's no x's, no y's anymore, and you end up with two constants that just are not equal to each other, well, then these lines would be parallel. Now, the other result is when the two lines are actually the one and the same. They're actually the same line, right? We talked about this as well. So if both lines kind of end up on top of each other, in fact, they're the same line, this means you have infinite solutions. Infinite solutions. Okay. By the way, you should probably write this down because it's going to come up repeatedly, okay, throughout this lesson and possibly the next as well. So in the case where the two lines are on top of each other, again, infinite solutions. Well, what would that look like when we try to use elimination? Well, this will end up with something where it's always true. So this is, for parallel lines, no solution. It's never true, right? 0 is never equal to 6. But in the case of infinite solutions, you end up with something that's always true. Something like 0 equals 0, right? This is always true, right? So there's no variables here to mix things up. Yeah, 0 equals 0 or 5 equals 5 or something like that. Well, in that case, there's infinite solutions. All right. So let's go ahead and solve some of these ones and you'll quickly see what I mean. So I'm going to go ahead and maybe just grab this first one. We're going to do elimination method here. Now, in this case, here, everything's lined up. That's good. It's already set up for us to use elimination. Here, if I want to cancel out my x's, let's say I want to cancel out my x's, I'm going to multiply by -3. That way I'll have -3x up here. So what will my top equation look like? Well, I'm going to go ahead and distribute this -3 here into every term, giving us that we have -3x minus 6x equals, and then -3 times 1 is -3. The bottom equation didn't need to change. You just keep it as 3x plus 6y equals 3. Whoops, I made a mistake actually. Probably some of you caught that. That should have been a 6y. Now, what happens when I add these equations together? Well, you can see that my x's cancel, but my y's cancel also. I have 0 over here, don't I? -3 and +3, well, that also cancels. That gives me 0 as well. Okay, 0 equals 0. That implies that there's infinite solutions because 0 always equals 0. All right, let's go ahead and try the next one. All right, in this one's case, let's go ahead and multiply this bottom equation by -2. That way I'll have 2x up here and then -2x down here. So the top equation doesn't change, so I'm just going to rewrite it. 2x minus 8y equals 17. And the bottom equation would be -2x plus 8y. And you can probably already see what's going to happen here, equals -14. Now, when I add these equations together, what happens? Well, my x's cancel, the y's cancel. That gives me 0 over here on the left. On the right, though, 17 minus 14 is 3. Well, this is just not true, is it? 0 doesn't equal 3. So that means these two lines would actually be parallel if you were to graph them. You could always graph them to see, actually. But these two lines would be parallel, and in fact, they have no solution. So the system has no solution. Let's go and work on the next one. For this one, if I want to cancel out let's say I want to cancel out the y's in this case. If I want to cancel out my y's, I would just multiply this top equation by -1. That way I'll have a negative 10y on top and a positive 10y in the bottom equation. So let's go ahead and distribute this negative 1 here into each term, giving us we have negative x minus 10y equals, and then negative 1 times 50 is negative 50. Okay, great. The bottom equation, no need to change. So 2x plus 10y equals 90. If they don't need to change the equation, I just rewrite it. So now let's go ahead and add these two equations together. Negative x plus 2x is 1x. I'll just put x. The y's eliminate, that's good. And then here we have negative 50 plus 90, which is 40. So now we actually have the value of x, don't we? So we actually found a value for x. That means there's actually going to be a single solution. So I don't even need to finish it by finding y. I know that there's going to be one solution. And in fact, if you were to go ahead and graph those two lines, you would see them crossing at 40 comma something. Okay. I think it's 40 comma 1 actually. Okay. Let's go ahead and do the next one. Alrighty. Well, once again, I'm looking at this and my y's are lined up, my x's are lined up, everything's lined up. So they've been treating us nicely with having everything lined up. That's good. Let's say I want to eliminate the y's. So in this case, I'm going to multiply this once again by negative 1. So that's going to give us negative 2y plus x equals negative 12. The bottom equation, no need to change it because the y's are already set up to cancel just like that. So now what happens to my y's? Well, the y's eliminate. Here I've got negative 1x. Okay, so the x's did not eliminate. And negative 2 here. Negative 12 plus 10 is negative 2 because you have more negatives. To finish solving for x here, I can go ahead and divide by negative 1 on both sides of the equation, giving us the value of x is 2. So here I actually found a value for x. So that tells me that these two lines will cross at some location. It'll have an x value of 2, so it'll be like 2 comma something, 2 comma 7, I believe. All right, let's go ahead and try the next one. This next one is a little bit worse looking because it has fractions, which generally I don't like dealing with fractions, but fortunately these fractions are easily dealt with, and I'll show you how. Notice that for that first equation, it has both the denominators are just 5. So if I multiply that equation by 5 or some other multiple of 5, it'll eliminate the fractions, which is good. They'll turn it into whole numbers. So one thing I could do, I'm going to go ahead and multiply this by 5. In fact, I'm actually going to multiply it by negative 5. And the reason why I want to multiply it by negative 5 is so that this will become negative 2y. And then down here, I've already got a positive 2y so that the elimination will happen on the y's. So let's go ahead and distribute this. And I talked about this multiple times in pretty much every video, is to multiply a whole number times a fraction. You take the whole number, you multiply by the top, and then divide by the bottom. All right. So here I'm going to multiply negative 5 times 2/5. So negative 5 times 2, which is negative 10, then divided by 5, which is negative 2. So I've got negative 2y, and then multiply the negative 5 times negative 3/5. Again, multiply times the top, divide by the bottom. So negative 5 times negative 3 is positive 15. 15 divided by 5 is 3. So that's 3x. And then we also need to multiply the negative 5 times the 1 here, giving us negative 5. The second equation has no need to change, so I'm just going to go ahead and rewrite it underneath. You can kind of see, hopefully you can see what's going to end up happening here. The y's and x's both cancel, giving me 0. Here, the 5's as well as cancel. That's 0. Is this true or false? 0 equals 0. Well, that's a true statement, isn't it? That's always true. So 0 always equals 0. In fact, that means there's infinite solutions because these two lines are always true together. Last one, I'm going to go and guess that this has no solution because, well, it's just a guess, but let's go ahead and multiply this one by -2. That way our x's will eliminate. The top equation has no need to change, so 4x plus 10y equals 40. And the bottom equation gets multiplied by -2 across, so -4x minus 10y equals -80. Here, eliminate, that's 0, equals 40 minus 80 is -40. Well, those are not equal at all, right? So that means that these two lines will have no solution. In fact, these two lines would be parallel if you graph them. All righty. Well, that gave us some pretty good practice as far as getting the elimination method down. Why don't you go ahead and try the practice, and I'll go over all the practice questions as well. But if you want to, just go ahead and try them on your own, and then just come and watch the video for any ones that you are stuck on. You're only going to have 5 practice questions and 5 questions on the mastery test. But I'm going to go over here 10 questions for the practice and 20 questions for the mastery test. So let's go ahead and get started here. And let's go ahead and try the elimination here. Determine how to rewrite one of the two equations above in the form ax plus by equals c, where a, b, and c are constants, so that the sum of the new equation and the unchanged equation from the original system results in an equation of one variable. Okay. So let's see here. Well, one thing we can do, let's say I want to eliminate the x's. If I want to eliminate the x's, I can multiply this top equation by what? Well, hopefully you can see I would multiply by 2. That way you'd get -6x here, which would eliminate with the positive 6x. So what does that look like? So our top equation now will be rewritten as -6x plus 8y equals 48. So remember, you multiply the 2 by every term in this equation. Okay, so I would just write this here, and that would be your answer. By the way, if you wanted to eliminate the y's instead, you'd multiply this bottom equation by -2. That way you'd get a -4y. But you don't do it both ways. Just try to eliminate one variable and work on that. Okay. Question 2. Let's see. Here we just want to solve this system using elimination. Well, let's go ahead, and one thing I'm noticing is, hey, wait a second. They didn't put everything in order, did they? See how they put the x's lined up, but they did not put the y's lined up. So that's a problem. We're going to have to rewrite this bottom equation so that everything's lined up perfectly. The x's, the y's, the equal sign, and then the constants. So let's go ahead. I'm just going to grab this equation, and to the side, I'm going to rewrite it. Okay. So here, -x minus 8 equals 3y. So what I would do probably is move the 3y by subtracting 3y on both sides. And then I'm going to add 8 to both sides. I'm kind of doing this all in one step, but if you need to use multiple steps, that's fine. So on the left side now we have -3x minus 3y equals, and then we have 8 on the other side. So now this bottom equation is in the same order as the top equation. So I'm just going to go ahead and rewrite the top equation. I'm just going to write it below here. 4x plus 5y equals 10. Now, if I want to use the elimination method, I'm just going to go ahead and multiply that top equation by something. So what do I multiply the top equation by if I want to eliminate the x's? So if I want to eliminate the x's, what do I multiply this top equation by? Well, hopefully you see I can multiply by 4. That way you have negative 4x here. So we have, rewriting this top equation, negative 4x minus 12y equals 8 times 4 is 32. The bottom equation has no need to change, so I'm just going to go ahead and rewrite it below here. Now we can add the two equations together, which will eliminate the x's. Here we have negative 7y. It's negative here because we have more negatives. And then we have 42. Go ahead and divide both sides by negative 7, giving us that y equals negative 6. So now we know the y value is negative 6. We do not know the x value yet, but we can plug in this y value and substitute it in to one of the original equations to help us find the value of x. So I'm just going to go ahead and plug it into this equation here. So you could use either equation. Both of them work equally as well. But I'm just going to plug it into this top equation. So let's go ahead and rewrite the top equation. But in this case, we're replacing the value of y, replacing y with negative 6, what it equals. Substituting. Okay, so that gives us that we have 4x. 5 times negative 6 is negative 30 equals 10. And see if you could solve for x here. I would add 30 to both sides. Giving us, we have 4x equals 40. Then what would I do to solve for x from here? Well, I would just go ahead and divide by 4 on both sides of the equation, giving us the value of x is 10. So 10 comma negative 6. In fact, if you were to graph these two lines, you should see them crossing at that exact point, 10 comma negative 6. All right, next question. Scarlett and Paola are on a vacation. They went to a store to buy some souvenirs for their friends back home. Scarlett bought 3 pairs of sunglasses and 2 shirts for $81. So let's go ahead and write the equation for Scarlett's purchases. It says that she bought 3 pairs of sunglasses. Sunglasses are going to be X, and then the shirts are going to be Y. Okay, so she bought 3 pairs of sunglasses, plus she bought 2 shirts, and the cost of her purchases is $81. Paola bought 1 pair of sunglasses and 5 shirts for $105. So what would Paola's equation look like? Well, 1 pair of sunglasses, so 1x or just x, plus 5 shirts, and the result is $105. So let's go ahead and solve this system of equations using elimination. In this case, it's probably easiest to solve or eliminate the x's in this case. What would I multiply this equation, this bottom equation, what would I multiply it by in order to cancel my x's? Well, hopefully you see I would multiply by negative 3. So that negative 3 gets distributed to each of the terms in this example. So let me go ahead and grab that. So what would be my new equations? Well, the first equation has no need to change. 3x plus 2y equals 81. But the second equation, the negative 3 gets distributed here. So that's going to be negative 3x minus 15y equals negative 3 times 105 is negative 315. Now, when I add these two equations together, the x's are going to eliminate, aren't they? So these eliminate. Here you have negative 13y equals then 81 minus 315. 81 minus 315 gives us negative 234. Lastly, to help us solve for y, we're going to divide both sides by negative 13, getting us y by itself. So y equals, and again, y is the cost of the shirt, right? So the shirt's cost in this case, $18. Great. So now that I know the value of y, well, now we know this is the answer, right? Because this is the only one that has the shirt being $18. But let's say there was multiple. We would take that 18 and plug it into one of the original equations. Here I would replace the y. I'm going to go ahead and replace it into this second equation here. So it'd be x plus 5 times 18 equals 105. That gives us that we have x plus, what's 5 times 18? I believe that's 90 equals 105. Then how would we solve for x here? Well, hopefully you can see that I would go ahead and subtract 90 on both sides of the equation, giving us the cost of the sunglasses is $15. And indeed, that's what we see here in this answer choice. Okay. Here we have another system. Find the solution. Okay. So here, let's say I want to eliminate my y's. In the case where I want to eliminate my y's, what would I multiply this top equation by? Well, hopefully you see that I would multiply by negative 2. That way we would have a negative 4y to cancel with this positive 4y. If you wanted to eliminate the x's instead, you'd multiply by negative 3. That way you'd have a negative 9x here and a positive 9x, canceling. But here we're eliminating y. So let's go ahead and distribute this negative 2 on this top equation, giving us negative 6x minus 4y equals a negative times a negative here. That makes positive 6. The bottom equation had no need to change, so 9x plus 4y equals 3. And if we did that correctly, we can see that our y's will eliminate. That's great. Negative 6 plus negative 6x plus 9x is 3x. So we have 3x equals, and we're adding here, so that's 9. Go ahead and divide by 3 on both sides of the equation in order to help us get x by itself. Dividing by 3, giving us the value of x is 3. So we already know the value of x is 3. So it's either this answer or it's this answer. I'm not sure yet. But what we can do is now that we know the value of x, we can plug that into one of the original equations and help us solve for y. You could use either equation. They both work equally as well. But I'm going to go ahead and plug it into this bottom equation here. So instead of 9 times x, it'll now say 9 times 3. Again, just using substitution. 9 times 3 plus 4y is 3. 9 times 3 is 27. So we have 27 plus 4y equals 3. Now, what would be my first step in helping me solve for y here? Hopefully you'd see that I could subtract 27 on both sides of the equation, giving us 4y equals negative 24. Lastly, to help us solve for y, we would simply divide both sides by 4 to get y by itself, giving us the value of y is negative 6. So yes, it's this last answer choice here. Next question. Sarah makes artificial flower bouquets and table arrangements and sells them at craft fairs. Last weekend, she collected $283 from selling 8 bouquets and 6 table arrangements. All right, so the bouquets, I'm going to call them X. The table arrangements, I'm going to call them Y. So let's go ahead and write our first equation. The first equation basically says she sold 8 bouquets plus she sold 6 table arrangements. And the amount of money she brought in, the revenue, was $283. Great. The week before, she collected $491, selling 10 bouquets and 12 table arrangements. So let's go ahead and write the second equation using that information. 10 bouquets plus 12 table arrangements. And the amount of revenue was $491. Great. Now we can go ahead and use elimination here to help us solve for X and Y. Here it's asking, what is the price of the table arrangements? So really they're asking, what's the value of Y, right? What's the value of Y? So since they're asking us for Y, we probably want to eliminate the X's, okay? Now, normally I would say, if I'm presented with this problem and I want to find X and Y, I would probably eliminate the Y's because that looks easier to eliminate the Y's. Just multiply this by -2. But since I'm looking for Y, I'd rather eliminate the X's, and then that way it saves me having to do the substitution. So if I want to eliminate the X's in this case, what can I do? Well, this is a little bit of a unique situation that we perhaps haven't seen before. What I would want to do is I want to multiply this top equation by -5. And I'm going to multiply this bottom equation by 4. Now notice here, I'm multiplying the top equation by something, and I'm multiplying the bottom equation also by something. Well, why am I choosing -5 here and 4 here? Well, let's go ahead and distribute this out and distribute the 4 out in the bottom equation to help us see why I chose these numbers. So -5 times 8x is -40x. -5 times 6y is -30y. -5 times 283 is -1415. For the bottom equation, I'm going to change colors here. For the bottom equation, that's going to give me 40x plus 48y equals 4 times 491. I have my calculator here, is 1964. Now, perhaps you can see why I chose these numbers. Look at what happens with my x's. Well, they're perfectly able to eliminate, aren't they? So it's a lot like finding the lowest common denominator when adding fractions. You're finding essentially the lowest common multiple. Well, that's the lowest common multiple for 8 and 10 is 40. So that's why I changed them both to 40. Well, one into 40 and one of them into -40 so that they would eliminate. Could you have chosen the bottom one to be negative and the top one to be positive? Well, yeah, that would have worked as well. So it just, that method would have also worked just as much. So it's just your choice. As long as you see that one of them is negative, one of them is positive. So when you add the two equations together, they will eliminate one of the variables. Okay, so -30y plus 48y is positive 18y. It's positive because we have more positives there. Then -1415 plus 1964 is 549. Go ahead and divide both sides by 18 to give us 30.5. So y equals 30.5, okay? Which essentially means $30.50 in terms of money, right? Because we're dealing with money. Okay, that was probably the hardest one we've done so far, but don't worry, it's not that bad. Most of these are not that bad. Okay, solve the system here. Okay, let's say I want to eliminate the x. Let's eliminate the y's again here. In order to eliminate the y's, what do I want to multiply this equation by? Well, hopefully you could see I multiply this by 2. That way I'll have a negative 4y to cancel with this positive 4y in the top equation. So the top equation didn't need to change, so I'm just going to rewrite it. 3x plus 4y equals 10. And then for the bottom equation, that 2 gets distributed to each term in that equation. It's 12x minus 4y equals 80. The 2 multiplies everything there. Now when we add the 2 equations together, the y's eliminate, giving us 15x equals 10 plus 80 is 90. Divide both sides by 15 in order to help us get x by itself, giving us x equals 6. So now that we know the value of x, we already know that this is the correct answer, right? Because it's the only one that has an x value of 6. But let's say we didn't know that. You could take this x equals 6 and you would substitute it back into one of the original equations. So here I could substitute it into either equation, but I'll just substitute it into this bottom equation. So that'll give us 6 times x becomes 6 times 6 equals 40. 6 times 6 is 36 minus 2y equals 40. Now, how would we solve for y? Well, hopefully you see I would subtract 36 on both sides of the equation. Giving us negative 2y equals 4. Divide both sides by negative 2. And that'll finish solving for y for us. Y is negative 2. There you go. Next question. The drama hosted a one-act play competition. The given table shows the number of student tickets and the number of adult tickets that were sold each night, along with the total sales. Write a system of equations that could be used to determine the price for a student ticket, X, and the price for an adult ticket, Y. So on Friday, let's go ahead and write the equation for Friday. So student tickets are X. So 40 student tickets plus 50 adult tickets pulled in a revenue of $615. So it looks like this is the right answer. Okay. You can see where the other equation comes from as well. 30 student tickets plus 45 adult tickets was 525 in revenue. So that's the second equation there. Next question. Alrighty. Okay, this one's a lot. System of equations and its solution are given below. Okay, system, and here's the solution. Okay. Choose the correct option that explains what steps were followed to obtain the system of equations below. X plus y equals 8. 10x equals 50. 10x equals 50. So it looks like they multiplied this top equation by 6, right? So I multiply this by 6. That gave them 6x plus 6y equals 48. And they added that to the bottom equation. Here it's a negative 6y. 2. The negative 6y and the positive 6y cancel, or in other words, eliminate, giving us 10x equals 50. So they multiplied by 6 on the top equation. Okay. So to get, let's read each of these. To get system B, the second equation in system A was replaced by the sum of that equation and the first equation multiplied by negative 10. No, should have been multiplied by 6. To get system B, the system of equation in system A was replaced by the sum of that equation and the first equation multiplied by 6. Yes. All right. This is not a very good question, but yes, that's what they did. Okay. Which value of B represents in infinitely many solutions for the system? So we have some value B here. Okay, and we're looking for a value for B that'll make this have infinitely many solutions. Now remember, infinitely many solutions implies that these two lines are actually the same line. So what I can do is actually create them in such a way where they look exactly the same. Okay, so notice this said the top one says 9x plus 6y equals B. The bottom one says 3x plus 2y equals 1. Well, hopefully you can see that I can multiply this bottom equation by 3, and that'll make it look just like the top one, right? That'll make it look like 9x plus 6y equals 3. Notice this looks just like this one, doesn't it? 9x plus 6y equals B, so that means the B must be 3. Alrighty. Drag each number to the correct location. Okay. Hillary plans to go on 3 rides and play 6 games. All right, so rides are going to be R. Games are going to be G. 3 rides and 6 games at the state fair, which will result in 42 tickets. So let's go ahead and write the first equation here for Hillary. 3 rides, so 3R. 6 games and 42 tickets. James will play 5 games. 5 games. So the 5 goes here on games. 4 rides, and you'll need 44 tickets for that. There you go, system of equations. Okay, now we're going to move on to the mastery test, and you're going to be offered 5 questions. 5 of the 20 questions that I'm going to go over. So please follow along if you can. Also, if you're not subscribed yet, you should do that, because it's just a way to say thank you for all the hard work I've put in. I mean, look how long this video is, and look at how long those other videos are. Yeah. So if you want to give me a thanks for all this hard work, all you have to do is subscribe. Pretty simple. Also, if you really want to say thank you, you could share it with someone else as well. Okay, let's go and look at question 1 from the mastery test. At the local market, Bill buys 3 juice boxes and 2 hot dogs for a cost of $8. All right, so let's go ahead and write that first equation. 3 juice boxes, so juice boxes are going to be X in this case, plus 2 hot dogs. 2 hot dogs are going to be Y, so 2 hot dogs, and the cost is $8. Sarah buys 2 juice boxes, so 2x for Sarah, and 1 hot dog for $5. Okay. The cost of each juice box is blank. The cost of each hot dog is blank. So if we're going to use the elimination method, let's go ahead and eliminate our y's first. That's what I would do. And so I would multiply this bottom equation by what? What do you think? If I want to eliminate the y's, well, I'd multiply by -2. So go ahead and distribute, combine and cancel things out, eliminate, and figure out what x is first, then plug it back in to find y. The length of a rectangle is 3 inches more than its width. Okay. The perimeter of the rectangle is 34 inches. Okay, so let me just go ahead and draw a rectangle. Okay. And by the way, you should be writing down everything I write. So it says in a rectangle, the length is 3 inches more than its width. So the width I'm going to put as W. The length is 3 more than that. So I can write it as the width plus 3 more. So whatever the length of the width is, plus 3 more. Now the perimeter of the rectangle is 34 inches. So perimeter means I'm adding up all the outside edges. So the perimeter of any shape is you're adding up the outside edges. So this top edge is also the same as the bottom edge, right? And this right is the same as the left. So the perimeter in this case would be W plus 3 plus W plus W plus 3. So if I add all that together, that's 4 W's plus 6. And according to this, the perimeter is 34 inches. Okay. So now we can find the length and the width. So the first thing I would do is go ahead and solve for the width here. So how would I do that? Well, I would go ahead and subtract 6 both sides of the equation, giving us that 4 times the width is 28. Then divide both sides by 4 to get W by itself, giving us the value of W, in this case, is 7. And that also means the length is 3 more than that. So that means the length, messed up a little there. The width is 7 and the length is 10 because it's 3 more. Okay. An admission fee for a charity event is $7 for children, $10 for adults. The event was attended by 700 people. So the number of children, are going to be X, while adults are going to be Y. So the number of children plus the number of adults is 700 people. So there's your first equation. Has to do with quantity. The second equation is going to have to do with the value of those, right? So for the children's tickets, it's $7 per ticket, plus the adult tickets, which are $10 per ticket. So $10 times the number of tickets there. And the amount of revenue was $6,400. So here's your system, and we're going to solve using elimination. The way I would do that is I would probably multiply this top equation. If you want to eliminate the x's, you'd multiply by -7. If you want to eliminate the y's, you'd multiply by -10. The choice is yours. See if you can finish it up. All right. Rewrite one of the 2 equations above in the form ax plus by equals c, where a, b, and c are constants, so that the sum of the new equation and the unchanged equation from the original system results in an equation with 1 variable. So essentially we want to rewrite one of these equations so that one of the variables eliminates. Well, if you want to eliminate the x's, what would I multiply this by? Well, you'd multiply by 4. If you want to eliminate the y's, you'd multiply this by 3. Okay, here I'll just multiply by 4. What would that new equation look like? -4x plus 12y equals 4 times 6, which is 24. Okay, so you'd replace A with -4, B with 12, and C with 24. Okay, complete the sentence to explain what steps were followed to obtain the system of equations below. I don't really like these type of questions, so I'll just go over it with you step by step. Here, if they're using elimination, it looks like they got 6y here. So they eliminated the x's, which means they probably multiplied this top equation by 3, resulting in 3x minus 3y equals 21. And the bottom equation is unchanged. Then if we add the two equations together, the x's eliminate. Here that gives us 6y equals -18, which is what they got here. Okay, so it looks like to get system B, the blank equation in system A was replaced by the, I would say the second equation in system A was replaced by the sum of that equation, and 3 times the first equation. The solution to system B is the same as the solution to system A. Okay. Next one. Here we're just finding the solution using elimination. So let's say, do you want to eliminate the x's or the y's? Well, in this case, it's probably easier to eliminate maybe the y's. So here I'd just multiply this one by 2. That way you'll get a -8y that cancels with this +8y here. And then you'll solve for x first. Then use then substitute x into one of the original equations to find y. Okay, did plenty of examples like this in the practice. Okay, next one, number 7. Mark is treating his family to ice cream. What a nice guy. He buys 4 sundaes. So I'm going to say sundaes, those are S, and 3 cones, cones are C, for a total of $26. So let's go ahead and look at this first piece of information to help us write the first equation. So 4 sundaes plus 3 cones resulted in a price of $26. Okay. Brian also buys ice cream for his family. What a nice guy. His total is $29 for purchasing 2 cones, 5 sundaes. Okay. 2 cones, so that's C, 5 sundaes, so that's S. Go ahead and see if you can put the correct numbers for this one here. Okay. Classify each system of equations as having a single solution, no solution, or infinite solutions. Wow. They really made this one a pain because you may notice that, first of all, there are 6 systems here to work with, and you have to do all of them. The second thing is that they didn't line everything up. You can see that some of these are not lined up nicely for using elimination. So, well, let's just start working through them, I guess. Some of them I'll ask you to do on your own, but for the most part, I'm going to do quite a few of these with you. So for this one, I would actually go about this by using substitution. Hopefully you watched the previous lesson on that. But I would go ahead and replace this y here with what y equals here. The reason I would use substitution here is because it's kind of set up to do substitution in that one of your variables is already by itself. So I'm just rewriting this bottom equation, replacing the y with what y equals from the first equation. I can distribute this negative here, giving us that 4x minus 11 plus 2x equals 7. I can combine the 4x and 2x, giving us 6x minus 11 equals 7. Go ahead and add 11 to both sides. 6x equals 18. And then divide by 6 on both sides to get the x equals 3. So x equals 3 in this case. So we actually found a value. So if we found a value, that means it actually has a solution. Okay. So if you actually find a value, you find a value for x, find a value for x or y, then it's one solution. If you end up with something that's not true, something like 5 equals 0 or something like that, this is not true. So this would have no solution. And if you graph the two lines, they would be parallel to each other. For infinite solutions, you end up with something that's always true, something like 0 equals 0. In the case of something that's blatantly true with no variables involved, then this would have infinite solutions. And in fact, the two lines are actually the same line. So if you graph them, they would just be the same line. All right, let's go ahead and try the next one. Here, I'm going to use substitution once again. Here it says the value of x is 12 minus 3y. So I can replace the x in this equation with the value from x from the first equation. So 3 times 12 minus 3y plus 9y equals 24. Go ahead and distribute the 3 here. So when I distribute the 3 into this parentheses, gives us 36 minus 9y plus 9y equals 24. Here, negative 9y plus 9y, well, I can combine those together, but they cancel. So that gives me that 36 equals 24. Hey, 36 doesn't equal 24. So those are actually no solution there, because you end up with something that's not true. You had 36 equals 24. Well, that's not true, is it? So no solution. Okay, next one. All right, for this one, I'm gonna use the elimination method. I'm gonna subtract 3y on both sides of the equation. So my top equation doesn't change. It's 2x plus y equals 7. And then on the bottom, we have negative 6x minus 3y equals negative 21. So notice in this case, I had to rearrange some stuff in the bottom equation in order to make things line up, right? I need my x's lined up, my y's lined up, the equal sign lined up, and then the constants lined up. So you need everything lined up before you could start thinking about eliminating anything. Now that everything's lined up, we can eliminate one of our variables. Here I'm going to try to eliminate my x's by multiplying by, not negative 3, actually positive 3. That way I'll have a 6x on top and a negative 6x on bottom. So go ahead and distribute this 3 into this top equation, giving us 6x plus 3y equals 21. The bottom equation had no need to change, so I'm just going to rewrite it here. Negative 6x minus 3y equals negative 21. And hopefully you could see what's going to happen here is that everything is eliminating, isn't it? So here everything cancels, that gives me 0. Here this cancels as well, giving me 0. When I add these two equations together, 0 equals 0, well, that's true all the time. So infinite solutions. These two lines are actually the same line. If you were to graph them, they would just be one line on top of each other. All right, next one. Okay. So here, this is actually the easiest one. These are already set up to eliminate. If I add it together, that gives me 3x. These eliminate, equals 30. I can divide both sides by 3 to get x by itself. Here I'm actually finding a value for x, aren't I? I found that x is 10. So if I find a value for either x or y, that tells me there is a one solution. Alrighty. Next one. Okay, so here I notice my x's, y's, and stuff are not lined up. So what I can do is maybe subtract 2y on both sides of this bottom equation. And that way I get my y's together on the left side here of this bottom equation. So the bottom equation will now read negative 4x minus 2y equals 14. Meanwhile, the top equation, 2x plus y, is 7. I can eliminate my x's by multiplying this one by 2. That way I'll have a 4x and I have a negative 4x in the bottom equation. So let's go and distribute this 2 here, giving us 4x plus 2y equals 14. The bottom equation doesn't change here. So negative 4x minus 2y equals 14. Here, what happens? Well, x's cancel, y's cancel here. Do these 14s cancel? Well, no, actually, they add together. That's 28. If it was negative 14 and a positive 14, then they would cancel. But in this case, they're both positive, so they actually just add together. But this is not true, is it? 0 does not equal 28. So because that's not true, this one goes into the no solution. I'm going to guess that this last one goes into infinite solutions, but let's just go ahead and check. And by the way, another way you can check is just by graphing them, right? Because if you graph them, then you'll be able to see whether they cross in one location or don't cross at all, or if they cross at infinite places, meaning they're the same line. Okay, so this one, once again, needs to be rearranged. So I'm going to have to add 8y to both sides of the equation. That way I get my x's and y's and everything else lined up. So I'm going to add 8y to both sides of the equation. Cancels here. So that's going to give me this bottom equation can now be rewritten as 2x plus 8y equals 12. The top equation had no need to change. So x plus 4y equals 6. Then I would multiply this top equation. Let's say I want to eliminate my x's. I'm going to multiply by negative 2, distribute it, giving me negative 2x minus 8y is negative 12. The bottom equation had no need to change, so just like that. And you can see everything eliminates, right? So this eliminates, giving me 0. This eliminates, so 0 up here as well. That's a 0. This is true always, so this one goes into infinite solutions. Okay, that was a long one. All right. Roy and Elissa are buying tickets for the annual school event. Roy buys 6 adult tickets, so adult tickets are going to be A, and 2 child tickets. Child tickets are going to be C, for a total of $66. So Roy's equation is 6 adult tickets, 2 children tickets, for a total cost of $66. See if you can find the equation that represents Elissa's buying. Oh, so 5 adult tickets, 4 children tickets, $62. See if you can figure out what that is. Which system of equations has no solution? Oh boy. Select all the correct answers. So you need to see which one of these have no solution. All right, this is a long one. Okay. Now they really did make this as hard as possible, or as annoying as possible, I should say. So let me go ahead and grab this. If I want to use the elimination method, first thing I would do is subtract 12y on both sides. I'm going to try to go through this relatively quickly. So sorry if I'm going a little too fast, but I'm sure you don't mind too much because this is a long one. One here. Now, if I'm going to eliminate something, I can eliminate my x's by multiplying by 3 here. So that's going to distribute, right? So that's going to give me 3x plus 12y equals 69. Then we have a negative 3x. The bottom equation had no need to change. So now when we add that together, this eliminates. 0 equals 70. Right, these cancel. Well, that's not true, so that one has no solution. So this one actually has no solution. So you'd want to click that one. Let's go ahead and try the next one. So once again, I would subtract 2y on both sides to get everything lined up, giving us 2x plus 4y equals 22. Then on the bottom, we have negative x minus 2y equals negative 11. If I want to eliminate my x's, I'd probably multiply this bottom equation by 2. That way we get negative 2x minus 4y equals negative 22. The top equation had no need to change, so I could just rewrite it. You can see here that if I add these together, this eliminates, and this eliminates. So you get 0 equals 0. Well, that would have infinite solutions. So we don't want to click that. This one would have infinite solutions. So don't click it. Let's go ahead and do the next one. Okay, here I'm just going to use substitution. Since it says x equals, I'm going to go ahead and take this and replace it in for x in the top equation. So that's going to be 2 times 15 minus 2y. And we also have a plus y equals 15. Go ahead and distribute this 2 here, giving us 30 minus 4y plus y equals 15. We can combine our y's together. I'm also going to subtract 30 both sides. And then combine these. That's negative 3y equals negative 15. Here I'm actually going to find a value for y. So this one actually has a single solution. Okay, next one. So in this case, I'm going to go ahead and subtract 2y on both sides. That way I have my y's, x's, and everything lined up, giving me 2x plus y is the top equation equals 17. The bottom equation, negative 4x minus 2y equals negative 34. That'll give me negative 2x. So in order to use elimination, I'm going to have to multiply this top equation by negative or by 2. So that cancels with the x's there. So that'll be 4x plus 2y equals 34. Bottom equation, negative 4x minus 2y equals negative 34. Okay, I think you got it from there. Okay, tell me whether that has no solution or what. Okay, then the next one. Here I would add x to both sides of this top equation. And then I would multiply this top equation by -2, giving us -2x minus 6y equals -20. The bottom equation, 2x plus 6y equals 7. So I think you can get it from there. Tell me whether that has no solution or infinite solutions or whatever. Okay, last one. Here I could use substitution, so I could plug this in to here. So that give me 4x minus the value of y, which is 13 minus 2x, equals -1. I can distribute this negative, so that's going to be 4x minus 13 plus 2x. So here we're not using the elimination method, but that's okay. Here we're using the substitution method. 4x plus 2x is 6x. We have 6x minus 13 equals -1. Then we would add 13 both sides of the equation, giving us 6x equals 12. So we're going to actually find a value for x here. So that tells us there's actually just one solution here. Okay. Oh my goodness. More of the same. So this next one, number 11 here, is a lot like the previous one. So if you need more examples, you could look above. Except in this example, we're looking for systems of equations that have infinite solutions. So you're looking for something that's obviously true, where something like 0 equals 0, or 2 equals 2, or -10 equals -10. So something where there's no variables, is just this constant equals this constant. This is something in algebra that's always true. So if you come across something like that, then that's what we're looking for infinite solutions. So let's go ahead and look for that. And I'm going to go over these 3 examples, the left ones, and you could do the other ones on your own. So let's take a look here. We could solve this one by elimination. How would I do that? Well, if I want to eliminate the x's, I would go ahead and multiply this by -3. That way you'd have a -6x with this 2, which would eliminate with this 6x here. So the top equation becomes -6x minus 15y, because that -3 multiplies with every term in this equation, equals, and then -93. Okay, and then for the bottom equation, it doesn't change at all. So I'm just going to go ahead and rewrite it. 6x minus y equals 13, and we could add those together. So in this step, the 6x's cancel, they eliminate, and then you have -16y equals, and then -93 plus 13 is -80. Divide both sides by -16 to get y by itself, and that'll show us that y equals 5. So if you actually get some value, y equals, in this case, 5, where you get some value for one of your variables, like x equals something or y equals something, that means that these two systems, the system of equations, has a solution, has one solution. So this case that has one solution, it's not infinite solutions. So this one's going to be a no. We don't want to click that. Let's go ahead and try the next one. Here, instead of elimination, this one's actually set up for substitution. And I can see that because it has y equals. So if you see one of your variables isolated already, y equals or x equals, then you could use substitution. And generally that's easier in that case because it's already set up for it. So it says y equals 14 minus 2x. That means I could replace the y in the next equation with 14 minus 2x. So how would I rewrite that? Well, it would be 6x, rewriting this bottom equation, plus 3 times y. Now the y is 14 minus 2x, so just like that, and then equals 42. So what would we do next? Well, we can distribute this 3 into this parentheses. So we have 6x plus 3 times 14 is 42 minus 3 times 2x, which is negative 6x, equals, and then we have 42 here. So you might see that, oh, the 6x and the negative 6x, they cancel. So you're left with 42 on the left equals 42 on the right. Okay, this is something that's always true, which if it's always true, like these, that has infinite solutions. So we do want to check this one. We do want to click that one. Now, I want to also show you how you can solve this graphically. In the case where that has infinite solutions, that means the two lines are actually the same line. So if you can graph the two equations, and if you see that the two lines actually equal the same line, then that actually has infinite solutions. So let me show you an example of that. Let's say you have y equals 2x plus 1, and then you have y equals 4x plus 2. 2y equals 4x plus 2, sorry. Notice that the two lines are actually on top of each other. So this has infinite solutions. So that's something you could check as well. It's just by graphing the two equations. And if you see that the two lines are actually on top of each other, then that's infinite solutions. So let me give you another example. Let's try this one. This is the third, the bottom left one. So let's go ahead and put these. So we have 2x plus y equals 14. 2x plus y equals 14. And then x equals 13 minus 2y. X equals 13 minus 2y. So in this case, they're not on top of each other. So this just has one solution. So this system just has a single solution. So this one we would not click because it only has a single solution. Okay, you can check the other three, try these on your own. Again, you're looking for infinite solutions like that. All right, here we could solve this by using elimination. I can multiply this top equation. Let's say I want to eliminate the y's. I'd multiply this top equation by 2. That way we'd have a negative 4y here, which would eliminate with this positive 4y here. So let's go ahead and distribute the 2 here to this top equation. 2x minus 4y equals, and then we have 30 here. The bottom equation had no need to change, so I'm just going to go ahead and rewrite it just as it is. Okay. From there, we can add the two equations together to cancel our y's. This will give us 4x equals, and then 30 minus 18 is 12. Go ahead and finish solving for x. Once you have x, substitute it into one of the original equations to find y. All right, number 13. William buys 2 bags of peaches and 3 bags of apricots for $17. So based on that first sentence, we could write an equation. So we're going to call the bags of peaches, we're going to call these x, and the apricots are going to be y. So for this first sentence, we could write the equation 2 bags of peaches plus 3 bags of apricots cost $17. So that's the first equation there. Let's go ahead and look at the next sentence. It says Sylvia buys 4 bags of peaches and 2 bags of apricots for $22. So what would be the equation from that information? Well, 4 bags of peaches plus 2 bags of apricots costs $22. So now that we have these two equations, see if you could solve, use elimination to find the cost of the peaches. So in that case, find x. So use elimination to help you find x in this case. What is the solution to the system of equations? Well, once again, we can use elimination in this case. In this one's case, let's say you can choose whether you want to eliminate the x's or the y's. Sometimes it's easier to eliminate x's, sometimes easier to eliminate y's. But in this case, it's about the same either way. So if I want to eliminate the x's, let's say, I would just go ahead and multiply this bottom equation by -5. That way I would have a -5x here and a positive 5x there. So this bottom equation, when I distribute this -5, is going to be -5x minus 20y equals -65. Again, multiplying the -5 times each term in that equation. The top equation didn't change, so I'm just going to rewrite it as it is. 5x plus 2y is 29. Then from there, we can add the two equations together and eliminate the x's, giving us -18y equals, and then 29 minus 65 is -36. Okay, I'm going to let you go ahead and solve for y from there. And then once you have y, use that solution you find for y to substitute it into one of the original equations to find the value of x. Select all the statements that are true for the following systems of equations. All three systems have different solutions. Okay, let's take a look at this last answer choice. System C simplifies to 2x minus 3y equals 4, and 4x minus y equals 18 by dividing the second equation by 3. Well, that looks true. I can divide this one by 3 to get this new equation. I don't know if that really helps you, but you can certainly do that. You're allowed to, just like we can multiply every term in an equation by something, you could also divide every term by something. In this case, you're dividing everything by 3, so that makes this true. Go ahead and find the solutions for each of these and see, do all three have the same different solutions? Do A and B? And then just click the one that's correct, basically. I'll help you by finding the solution to one of these systems. So we can do that. Let's go ahead and find the solutions for system A here. So what I think I want to do is multiply this top equation by -2. That way I'll have -4x here, which would eliminate the positive 4x in the second equation. So let's distribute this -2 in for every term in that equation. So -4x plus 6y. Notice it's positive here because a -2 times -3, negative times negative is positive, equals -8. The bottom equation didn't need to change, so it just gets rewritten as it is. Now, when we add the two equations together, what happens to my x's? Well, they eliminate. We have 6y minus a y, so that's 5y. And then the -8 plus 18 is 10. We can divide both sides of the equation by 5, giving us the value of y is 2. Okay, so now we know the value of y. And what we could do is take that solution for y and substitute it into one of the original equations to help us find x. You can substitute it into either equation. Here I'm going to substitute it in for the bottom equation, the second equation. So I'm going to rewrite this bottom equation, except instead of y, I'm going to replace it with 2. So that's going to be 4x minus 2 equals 18. Then what we can do is add 2 to both sides of the equation. Here we're solving for x essentially. So that'll give us 4x is 20. Divide both sides of the equation by 4 to help us get x by itself. Giving us the value of x is 5. So the solution A has the answer 5, 2. So 5 for the x, 2 for the y. See if you can find the solution to both these systems and then determine which of these statements is true. Okay, so here we want to find the solution here. Here it might have no solution. Here it might have infinite solutions, or these could be one of your solutions. If it has no solution, that's when you have something that's not true. So it might show up with like something like 0 equals 5. Well, that's not really true. They're not equal. So in the case where you end up with something like this, then you have no solution. In other words, the two lines would be parallel if you were to graph them. Infinite solutions is when something like this, 0 equals 0, or some other constant equals itself. So how can we determine what kind of solution it has or what its solution is? Well, we can use elimination. I can multiply this top equation, in this case, by -2 if I want to eliminate the y's. So what would that look like? Well, let's distribute the -2 into each term into this equation. So -6x minus 2y equals, and then the -2 times the 17 as well, -34. The bottom equation had no need to change, so it remains as is. Notice my -2y is going to eliminate with the positive 2y there. So these eliminate. -6x plus x is -5x. -5x. And then -34 plus positive 49 is positive 15. Okay. Go ahead and finish solving for x here. Well, we could say this is not right and this is not right because we're actually getting an answer for x. So we know it actually has a solution, a single solution. Okay. Number 17, an office supply company orders packs of pens for 2 of its stores. The first store orders 60 packs of ballpoint pens and 25 packs of gel pens for a total of $355. Okay, well, the ballpoint pens we're going to call X, and the gel pens we're going to call Y. Okay, so let's go ahead and write the first equation here. 60 packs of the ballpoint pens, so 60X plus 25 packs of the gel pens, so 25Y equals 355. Okay, so that's your first equation. We got that from the first piece of information they gave us. Now, what about this second piece of information? See if you could write the equation for that. You should get something like 120x plus 30 packs of gel pens, it says, so 30y equals 570. Okay. See if you can finish solving for x and for y here. X will be the cost of the ballpoint pens and y will be the cost of the gel pens. Okay. System equations and the solution are given below. So we have a system and its solution. All right. To get system B below, the second equation in system A was replaced with the sum of the equation of the first equation in system A multiplied by 2, -2. Okay. To get system B below, the second equation in system A, so that's this one, was replaced by the sum of that equation and the first equation in system A multiplied by -2. Okay, that's complicated. So basically what they're saying is they multiplied this by -2, which makes sense. And then they added these together. So they multiply this by -2, so that'd be -10x plus 2y equals positive 22, because it's a negative times a negative, that makes positive. And then the bottom equation, 3x minus 2y equals -8. And then you go ahead and add these two equations together. You should see that your y's will eliminate here. Your y's eliminate, giving us -7x equals 22 minus 8 is what, 14? Divide both sides by, so the I believe that's what they're looking for, -7x equals 14 here. So it's either, these both have that, right? So it's either C or D here. And the solution should be the same as, right? So the solution to this new system will be the same as the solution to the previous system. Okay. Consider the following system of equations. 2x minus y equals 12. Negative 3x minus 5y equals negative 5. The steps for solving the given system of equations shown below. Okay, so step 1, they multiplied the top equation by negative 5. Okay, see that there, negative 5. And then they distributed that negative 5. So that gave them the negative 10x plus 5y equals negative 60. Okay, negative 10x plus 5y equals negative 60. So that looks correct. The bottom equation gets rewritten. It has no need to change. So negative 3x minus 5y equals negative 5. Then they add the equations together, and the x's eliminate in this case, or sorry, the y's eliminate. So that's negative 13x equals negative 65. So there you have that. That looks good. Then you divide both sides by negative 13 to get x by itself, giving us the value of x is 5. So they did that correctly. Okay, good. Then they take this 5 and they plug it into x into this equation. So they replacing x here with the value 5. So that's going to become not 2x anymore. We're replacing or substituting the x. So 2 times 5 minus y equals 12. And looks like they have that correct. Okay. Then let's go ahead and solve for y here. So that's going to be 10 minus y is 12. Subtract 10 on both sides of the equation, giving us that negative y. The negative sticks on the y is 2. Divide both sides by negative 1, giving us the value of y is negative 2. Okay, so we got that as well. Okay, so let's see what the question asks. Select the correct statement about step 3. So let's look at step 3 here. Okay. Let's see. When negative 10x plus 5y equals negative 60 is added to this, a third linear equation, 13x is formed, and it shares a common solution with the original equations. That sounds correct, but let's go ahead and read the rest to make sure. When these equations are added together, a third linear equation is formed, and it has a different solution. No, that's wrong. When the equation is subtracted from, no. Yeah, I would say A is correct here. Okay. Last one. A fabric store sells 2 types of ribbon. One customer buys 3 rolls of the lace ribbon and 2 rolls of the satin ribbon and has a total of 120 yards of ribbon. So that represents, that piece of information is going to be our first equation. The lace ribbon is going to be X, and we're going to have the satin ribbon be Y. So this first sentence gives us the equation that 3X plus 2Y is 120 yards. So 120 there. See if you could write the second equation based on this second sentence. So another customer buys 2 rolls of lace, so 2X, 4 rolls of the satin, 4Y, total of 160 yards. Okay, so now we want to figure out the amount of yards in each roll, basically. So how would we do that? Well, what we can do is use elimination. We want to find X and Y. X will be the amount of, or the length in yards of the lace ribbon, and Y will be the length in yards of the satin ribbon. So we can use elimination here. In this case, perhaps multiply this one by -2 is the easiest way. That way you'd have a -4y here, which would cancel with the +4y in the bottom equation.
Okay, solve for y, then plug it back in, solve for x. Okay, well, I hope that all made sense. Hope you're able to get through it. By the way, like, comment, subscribe if you found this helpful. And also, you should share it with other people. The more people I'm able to help, then the better it is. Okay, well, with that, take care, and I'll see you guys next time. Good luck.